Hello, everyone, and welcome. Thank you all for joining us for today's session. My name is Firas, and I'm the event planner for Microsoft Reactor in Redmond. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary and remain professional and on topic. This session is recorded. It will be available through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link to our YouTube channel in the chat. I'll also be sharing some links to the Reactor Meetup page and the link to our survey to know your feedback about how this event went. Which brings us to our session today. This session will run for approximately an hour with time for questions within. Our speakers are Anthony Chu, he's a senior program manager, Mike Morton, principal program manager, and Sam Wronski, a regional cloud advocate. I am now going to pass this along to our speakers.
Awesome. Hello, everybody. We're here sort of after build, kind of covering some of the fun new announcements that have happened during build to kind of give you a better look at some of the features that came out. One of the features we're looking at is Azure Container Apps, which recently went generally available. And so Anthony and Mike have both worked on this. And so we've kind of brought them on to talk a little bit about what this product is, how you can use it, and maybe how you can get started adopting it yourself. So Anthony and Mike, do you want to talk about what is Azure Container Apps?
You bet. Actually, I have a couple slides, and then we'll jump into just demos and questions the remainder of the time, so don't panic. Azure Container Apps, we just went general availability at build on May 24th, so we're pretty excited. Let me go ahead and advance this. Azure Container Apps, it's a great serverless place to run all of your container apps and stuff that you have. It's great for microservices. That's one of the best places to run microservices in Azure. It's built on a lot of modern standards, so you can be ensured that what you're building on is made up of a lot of open source and open standards, such as Kubernetes, Kata for scaling, Dapper for those microservices. Dapper is a great platform for your distributed application platform. That's what it stands for. Runtime for the R. And also Envoy. So for all of your ingress and traffic splitting, we use Envoy. It's really meant so that you can focus on your apps and not have to worry about the infrastructure and the complexity of Kubernetes. It's not just good for microservices. And Anthony, feel free to chime in on any of these, but microservices is one of the key things that you can run. So you can have many of those small microservices talking to each other. Container Apps has a concept called a container app environment, which gives you kind of this, but it gives you this isolated network area to run multiple containers that can talk to each other. All of the logs for all of those containers go to a single place in log analytics. You can do event processing. That's another one that is great because with the Kata scaling that we have, your app can scale up to as big as it needs to when it has a tremendous load. But it's also can, if you set your minimum scale setting to 0, and we may have a demo for that later, it can scale all the way to 0. And at that point, you're paying nothing. You're paying nothing for that environment. And if all of the apps have scaled to 0, it's basically free. So that's a really great benefit and something that differentiates us from some of the other container runtimes inside of Azure. And of course, you can run traditional web applications, public APIs or private APIs, even just API endpoints. And another great one is background processing. So if you have some long running background processes, Azure Container Apps could be a great place. And as you can see down at the bottom of this slide, these different workload types can scale based on different criteria, such as your CPU or memory, your HTTP requests, maybe your message queue. So whatever you're pulling off of message queues, whether that be service bus or something else, you can scale in different ways. So that's kind of the types of apps that you can run on Azure Container Apps. And I'm not going to go and talk through all of these, but here's just a list of since we went to public preview back in, it was November, I believe, right, Anthony? We went public preview, and now GA in May. This is just it's a pretty good set, but it's a subset of all the things that we've enabled for great end-to-end developer experiences inside of container apps. Some of the big things I'm going to call out here are many more regions. We now support many more regions. Managed identity, so each of your apps can run with its own system or user identity, which is really great. The ability to have a custom domain. So if you are putting up a website and you want it to have a custom domain, you can bring your own certificates and have that custom domain surfaced for your container app. And then, like you can see, we have liveness probes and lots of observability improvements, which we'll show you some real soon. And then we have integrations with Visual Studio and VS Code, and Anthony and I will show you those also over the next few minutes. Anthony, did I miss anything in those intro slides there?
No, you did great.
Well, thank you. So Anthony and I do have a really lightweight demo, but it's just to introduce kind of what you can do in Visual Studio and Visual Studio Code. So I plan to jump into that unless there's specific comments or questions that anyone has so far. I don't see those, Sam. So if I'm missing those comments or questions for Anthony and I, let me know.
I know that so far there haven't been any, but
Okay, great.
opening the up to the chat, if anybody does have questions, this is a great time to ask the team about this product. So if this is something you're interested in and want to know more, ask away. Okay.
And while they're maybe typing or asking their questions, I'll go ahead and jump over to the start of kind of the small pre-planned or canned app or demo that we have here. So let me go out of there and come over here to Visual Studio. So I'm going to start with a really super simple .NET Core, basically just a web API. And I'm going to deploy this while kind of real time here. And then I'll turn it over to Anthony, because this backend API is one of two services that makes up this admittedly pretty simple microservice, but it shows you how two container apps within a container app environment can talk to each other. So I'm going to start here. You'll see here with this .NET Core application, it's really got just this one API here to return the albums here. I do have a couple of other endpoints, and these are for health probes and liveness probes. And so I use this to actually test out health and liveness probes. So I have both a health good and a health bad endpoint. Typically, you wouldn't have that in a real application, but it allows me to show how the liveness and readiness probes work, both when they fail or when they succeed, which is what you'd hope. But the main part of this application is just a simple albums endpoint that's going to return this list of 5 or 6 album endpoint or albums as an API. And then Anthony will show you the front end UI that leverages this API. So with that, I don't see any questions still, so I'm going to continue. I'm going to go ahead and show you the publish facility inside of Visual Studio. So I'll just right click there on my application and I'll click publish. And I publish just as a practice before I started. Number of Azure points that you can deploy to. And the one that we're going to use today, of course, is our Azure Container Apps. Go ahead and select that, click next. So here I can pick an existing container app, and in this case, in this subscription, I have 4, but let's go ahead and create a new one. Maybe this is your first time. Right in here within Visual Studio, I can create a new one. I'm going to name it something simple. We'll just call it Album API. I am going to pick a resource group that I already have that Anthony and I agreed we would share. And I think that started with M for music. I thought that would be the default, so sorry, I'm having to search through many.
Yeah, you've been busy here, Mike.
Well, if you notice, a lot of these resource groups actually start with Anthony's initials. So I haven't been as busy as Anthony has been.
Yeah,
But
yeah. And my name starts with A, so I like it. Like it's always at the top of the
it's
list.
always at the top. Yeah, mine is either Mike or music, and it's always hard to find, as you saw there. But I did.
We found it.
Found it. Yeah, search is a great thing. I also have already created a container app environment, but if you hadn't had a resource group or a container app environment, you just can click the new button and create one on the fly right inside of Visual Studio. So that's pretty handy. But we'll go ahead and create the one that I already created. And so the container app name is right here. Within a container app, technically you can have more than one container. Typically you're gonna have one container, but you may have a case where you want to have a sidecar container to do some specialized logging or authentication. We're not going to have that in this case, so I'm just going to call this container my main container. If you leverage Dapper, by the way, which is Dapper's built into the platform, it's optional, of course, but when you do use it, Dapper will actually start up a sidecar next to your application container, and that's how Dapper works. It communicates between those different sidecars for each of the applications. So that is a use case for a sidecar. But in this case, we just have one, so I'll go ahead and create this container app. This will usually takes 30, 35 seconds or so. It's a demo, so it'll probably take less. Knock on wood. Usually takes longer when we're doing demos, right, Sam?
Yeah, demos can be a little bit interesting.
Why is that? There's just something about those live demos that always just make it fun.
I did have a question, actually. The container name, is that the label in your container registry that's getting assigned to this container image?
So no, it is not the label or the
Okay.
tag. This is actually just a friendly name of the container that's running inside this container app. I could have a main, and I could have let's say a logging sidecar if I had a second container. So it's just a logical name to reference if you have more than one. If you only have one, it's pretty moot. It doesn't matter what you call it, to be honest. So we just created our container. Our container app was created, and here it is. You can see I called it the Album API container app inside of this resource group. And now all I have to do is pick where do I want to place this container image when it's built by Visual Studio. And so I'm going to go ahead, and I already have a container registry here called Music RG. You can see the pattern here of music and album. Again, though, if I needed to create a new one, I can do that again right in line and create a container registry. That takes a few seconds, so I created one ahead of time. And we have already, going to open it up. There it is, Music Reg, and I'll click Next. And now it's time to make my final decision, which, because this application that I've opened up in Visual Studio, this project, it was actually something that I did a Git clone from GitHub. And so because of that, I actually have this second option where if I don't want to interactively publish this application, I can actually use this second option, and it will generate a workflow inside of my GitHub repo. And that workflow will kick off anytime I do a commit. And it will use that CI/CD process to deploy rather than an interactive process. And we can demo that later if that comes up. And for now, though, I'm just going to go ahead and do a interactive publish so I can show you that. And just have to wait for all of those parameters to be saved. And the reason we save all of those selections that I just made is so that the next time you want to publish, when I do right-click publish, this screen will come up. I don't have to answer any of those questions. And all I need to do is click publish on future times. And so that's what that pub XML file that it just talked about on the previous screen. It's all about making that second or third or 20th publish from Visual Studio a one-click operation. And so what you'll see down here in my output window is what Visual Studio is going to do is it's going to use this Docker file that you can see over in the Solution Explorer. And it's going to use that Docker file to build a container image locally. And then it's going to publish or push that container image up into the ACR, the Azure Container Registry that I selected. And then lastly, it will use that image in ACR to actually deploy to container apps up in Azure. And bada bing, we'll have an app running in Azure with 2 minutes of work, which I could have done a lot quicker if I wasn't talking, but obviously I thought it would be good to show you some of the steps and talk about them. So there we go. our container app is up and ready. It actually launched it over here on this other window. I'll drag this over. And this is what it launched for me. And you can see we have our Happy Flower container app. We just pick random names to make sure they're all unique and distinct. And if I do a /albums, I should see, there we go. I can see all of those albums that we're running in this API. All right, so we have our app up and running. Let me do one other thing here. Let me actually show you that in the portal. So I'm going to right click on this, or click on this 3 dots, and I'm going to open this in Azure portal. Of course, it went over to another window. We don't want to make it too easy, right? Here, let me stack these together. That might be easier. So here we are up in the portal. There's the album API that I published to my music resource group inside of my music environment. So that container app environment that I talked about. In fact, let me click on that. That's that logical, isolated environment that has a truly isolated VNet for all of these container apps to run inside this environment. You can have multiple container app environments, but you'll want to run all of your related container apps that are part of maybe a larger app or microservice, or just a kind of a logical grouping of applications that may or may not want to talk to each other. You'll want to run those inside of a single environment. And then maybe you'll have another second or third environment for another logical group of container apps. But here you can see we have our apps, and there's only one. It's that album API app. Let's do this. Let's just show 1 or 2 things, and then I'm going to give Anthony kind of a fair warning that I'm going to be sending it over to him in a minute here to show you how to deploy the front end of this. But let me just show you like 1 or 2 things. We now have log streaming, so I can real time see the logs coming out of this application. So I have a single replica because I'm not scaling. So replicas are kind of they are instances of your application. So we have some scale that I have here, but I really haven't hit this thing more than 1 or 2 times. Let me clear these logs, and let me go back over to, where was that endpoint that I had? Tell you what, I'll open up another one so we know it's real. So I'm going to go back up here to the overview panel. I'm going to click on the application URL, and it's going to open it right there. Great. And I will go over here and do albums again. So we are actually hitting the endpoint. There we go. Now back to the portal, and I'm going to go back down to that log streaming that I showed you just a minute ago. And the log streaming is going to connect and start. I'm going to clear this, and then I'm just going to go over here, and I'm just going to refresh this a couple times. Like, let's just do 1, 2. And then back over the portal, and you can see that I can easily look at those live logs that are streaming through. That's a really helpful thing when you're trying to debug your application. I'll show you one more, and then I'm going to turn it over to Anthony, and then we can come back and dig deeper into this. We have a console also. So we have the log streaming, that's real time. I can also connect here to any of the containers inside of this, and I just only have one. And you can see here, if I do like an LS, here we are inside of that container that's running up in the cloud, and I can see and run any of the shell commands that I might need to, maybe to look at a file, or to change it, or to look or tweak a configuration or something. So these are 2 of the really helpful developer features that we've added at least recently to help you debug and diagnose your container apps there that are running up in the cloud. Okay, I'll stop there, and then we'll come back and we'll look at more of the revision management and the scale and stuff like that. But for now, Anthony, I'll let you take it away and present your screen and show the front end of this application.
All right, sounds good. That was awesome. Yeah, so what Mike and I kind of want to show you is, like how a getting started workflow, of 2 developers kind of working together on kind of building their first container app. And Mike kind of touched on this earlier, that you probably want to, set up proper CI/CD pipelines in GitHub Actions or Azure DevOps for this, for real production app. But the tools that we've been using with Visual Studio and Visual Studio Code are really useful for kind of quickly iterating on something until we get to a good point, and then we'll convert over to a proper CI/CD pipeline. So we thought that we would go through the same process and deploy a front end to to this albums app here that talks to the API that Mike has deployed. And I'm on a totally different machine. I'm in VS Code. This is a Node app. The app that the API that Mike published was a .NET app. So I'm just going to really kind of show you how two apps can run together in an environment. So the first thing that we need to do is this app that I'm starting with doesn't even have a Docker file. So we can't even turn this into a container image right now. So that's the first thing that I'm going to add is I'll kind of go and use this command here from the Docker extension in Visual Studio Code that allows me to add a Docker file pretty quickly. And you can see that there's a whole bunch of different languages and frameworks that I can use. But I know that my app is Node, so I'm going to choose Node. And I know that it runs on port 3000, so I'll take that. And I don't need a compose file. And VS Code will take care of creating my Docker file for me. I don't really have to even know what it means right now. I'm just going to take it as is. So now I can actually take this and publish it to the container registry that Mike was using earlier. So I'm just going to right click on my Docker file. I know it's a little bit small, but the option that I'm clicking on here says build image in Azure. And I'm gonna go ahead and kick this off first, and then we'll talk about it later. So let's call this, I don't know, music store. And I'll choose the same registry as Mike. What is it called again? Music Reg. And Linux. And what it's doing now is it's actually taking all the code on my computer and sending it off to Azure Container Registry. So there's a few benefits to this. One is I don't actually need to even have Docker installed locally to build my Docker images. And also because it's running this Docker build in the cloud, it actually runs a lot faster because it's actually running in the cloud and not using my slow internet connection. And then at the end of the build, normally I would have to push that image from my machine up to the container registry. And again, it's going to happen a lot faster when it's running in the cloud versus having my very slow home internet here. So after about 35 seconds, my image has been built and pushed to the registry. So the next thing that I want to do is open up the container apps extension in Visual Studio Code, and I can see all the environments that I have in my subscription. And this is the one that that Mike deployed earlier. So I can actually right-click on this and browse to it. It looks like just like with Mike's, it actually opened up on a different browser or in a different window. So I'll kind of drag it over here to show you that this is the same app that Mike deployed earlier.
And by the way, you'll know it's my app because it has Rush as the top art album, which is pretty obvious. Rush is the greatest band ever.
Excellent choice. Can't argue with that. All right, so that's so like I'm gonna go ahead and publish my own app. So I'm gonna right click on this and say create container app. And then I get to give it a name. So I'm gonna tell it music store. I can call it anything I want, but music store sounds good. And then it's going to want the container registry. So I'm going to choose that.
And Anthony, that's where it's going to pull that container image that you just built, right?
Yep. And then I can choose it. Actually, you know what? One thing that I forgot about is that in order for this app to run, I actually need to tell it where Mike's API lives right now.
The backend API.
Yeah, so I'm actually going to switch over to this and actually grab this URL from here. And I'm going to go ahead and put it into a file, just a regular .env file. Paste that in there. And then I'm going to use this in my deployment. So I'll do the same thing as I did before, which is right click on this environment, create a container app. Give it a name, music store, registries, music reg. I'm going to select my music store. And that's the tag that I deployed earlier. And I'm going to say that I want to use some environment variables from a file. And I can, like, it already knows that I might want to use this one, so I can just choose it. And then the next thing that I need to do is tell it whether or not this app needs an HTTP endpoint, and it does. So I'm going to say enable. And we get a choice of an internal ingress or an external ingress. So an external ingress allows applications, or basically things outside of the container apps environment and network, to access my app. Whereas keeping it internal will only allow different apps within the same environment and VNet to be able to call my app. So I want this to be external, so I'll choose that. And I will choose 3000. I think that's the one I chose earlier when I built the image as the port to expose. And then I'm just going to press enter. And just like with mics, we're going to sit here awkwardly as this thing deploys.
Anthony, a quick question. The base URL you're using here is the full URL. Is there a way to shorten that when you're trying to communicate inside of a container app, or?
Currently, no. So we've gotten this feedback quite a bit, and we're looking at ways to actually simplify that. So currently, we do require the full URL.
Okay, so that'd be something you want to use Dapper for right now, for communicating with. Okay.
Yeah, that's definitely something that we could do. So with Dapper, you can actually call a sidecar, and the sidecar takes care of calling this other service for you. So you would be using a simplified, like a simpler URL, and you would just refer to the Dapper app ID when you make that call. So that's definitely one way to get around this. Another way to get around it is obviously just using the full URL, as I've done here. But hopefully in the future, we'll have some simplified options for service discovery.
Awesome, thanks.
Cool. And then this button is here. I'll click browse, and there we go. We have our application running. And behind the scenes, it's actually calling Mike's API to display the albums. And like Mike says, you know that it's his because it starts with Rush.
Awesome. Great job, Anthony. So yeah, so that's our two service microservice with the Node front end and then the .NET back end. Of course, this is a pretty darn simple example of a microservice. Typically, you could have, or often you'll have many microservices, which the benefit there, of course, is each one should and could be independently deployed, independently scaled. And in fact, Anthony, would it be okay if I go ahead and maybe show some of the scaling stuff while we're waiting to see if questions come up? We'll just kind of go through some of those. Does that work for you?
Yeah, I actually have a scaling demo too, but you can show yours.
Actually, I don't have one ready. I was just going to wing it. So why don't you go ahead?
Really? Well, mine would be maybe slightly better than winging it. I don't know, actually.
I don't know. Sometimes my demos that I wing turn out to be some of the best demos ever.
Oh.
So I'll go ahead and watch what you have prepared.
Oh, well,
Pressure's
you're
on.
not depriving the internet of your wing demos that are supposedly legendary. So, so I'll try to at least match that. Try. I don't think it's going to happen. So I'll kind of quickly show you an app. Has to do with dogs. And I have it deployed to a different container apps environment. You don't have to worry about that too much. But it's an app that all it's doing is that it's listening to a queue, and the queue, what we're dropping onto the queue is one or more messages containing a URL to an image of a cat or a dog, and actually I trained this model myself using computer vision or custom vision in Azure, and kind of just packages up into a little Python app. Then all it does is it just keeps pulling queue messages off of a queue and just kind of figuring out if it's a dog or a cat, and then sending that information back to a front end. So I won't show you too much about how the app works, but I will show you the front end of this app. You can tell that I built this myself because it's the simplest bootstrap UI that you can think of. So I can go ahead and click classify images, and it's going to drop 10 messages onto the queue. And you can see that it's kind of processing things pretty slowly. But there's actually a lot of things going on there. When I click the button, it dropped 10 messages onto a queue. And then my little Python app there picked it up. And yeah, it's like, and then it's like, and then it downloaded the picture, and then it figured out whether or not it's a cat or a dog. Hopefully most of these are correct. If not, then you can blame the person who trained the model, which is me. And then, so that's with a single app here, a single instance, as you kind of saw there. So I will kind of go and show you the scale setting on this app. And you can see that I have it set between 0 and 20. And then here, I have it set to a queue length of 10. So all it's really going to do is it's going to look at the queue. So it's using a component, an open source component called Kada, and it's able to like listen to or kind of like inspect multiple types of event sources and scale your app based on what's happening in those event sources. So in this particular case, it's an Azure queue, and I have it set to a queue length of 10. So basically, what it's trying to do is it's going to take however number of messages that are in my queue, and then divide it by 10, and then that's how many replicas it will try to scale my application out to. So I just dropped 10 messages onto the queue, so it kind of just scaled it out to only one instance, and that one instance slowly processed it. But what we can do now is kind of see what happens if we drop a whole bunch more into it. So usually 2,000 is a pretty good number. It will take a little while, though, for my front end to start dropping all of these messages into the queue. But hopefully pretty soon, Kada will pick this up and then start scaling it out. Sometimes it takes a little while because it's not always checking the queue, because that would be very expensive. But it is checking it once in a while to kind of see how many messages there are. So, you can see that it's starting to go up now. And I think within about 3 or 4 minutes, it would get up to about 20 replicas. Yeah, let's see what else we can look at here. So another thing that we added, actually Mike helped add, is a way to kind of monitor how many instances your app is scaled up to, or replicas your revision is scaled up to. So here I can actually go and choose replica count, and you can see that it's still showing 1, but hopefully pretty soon, like, what's the lag on this? Probably like about a minute or so.
Yeah,
but hopefully pretty soon this
should be less than a minute, for sure. So
okay, well, we'll see if this goes up, but we'll actually be able to see in almost near real time, the number of replicas they are processing. And you can also see in the front end. So basically what the front end is doing, it's just kind of like inspecting these worker IDs behind the scenes to see how many in the last, 10 seconds, or how many different workers it saw in the last 10 seconds, and displaying it up here. So it's going to start, slowly kind of scale up and to about 20 replicas.
And as we mentioned earlier, while this is running, queues isn't the only way that you can scale using Kada. Obviously, there's CPU and memory is another really common way to scale, especially for things that aren't HTTP driven. And then, of course, there's just HTTP requests is another common way to scale. So Kada's pretty powerful, and there you go. I think you're showing some of the scalars, right, Anthony?
Yeah. So there's a lot of different types of scalars, and I think most of these work on container apps out of the box. So you can see a bunch of kind of like pretty popular open source things that you can scale on, like RabbitMQ and Redis. There's also a bunch of Azure services here that you can scale on, like we just saw Azure Queues earlier, but the Service Bus, Event Hubs, Blob Storage, you name it. The typical CPU and memory as well, and also even stuff on other clouds, as you can see.
I'm a little curious. How does cold starting work for these new instances, the new replicas you're starting at? What kind of delay does that look like, and how does that scaling actually operate? It looks like it's scaling linearly, so creating a new replica and then saturating that one and then creating another one. Can you talk about that a
Yeah,
little
so
bit?
it happens fairly quickly in that we provision a replica for you fairly quickly, but then we have to basically pull the image down and then try to start it. I don't think I wrote that that Python thing, like my Python app, too well. So there is a bit of a startup time, but that's mostly because of what I have inside of the container and the way that I'm pulling the queues. But yeah, it should scale up quite a bit, quite quickly. And yeah, like I said, I usually see this scaling up to about 20 in about 4 to 5 minutes. So yeah, so as we kind of keep watching, we can
and behind the scenes, I believe the infrastructure actually looks every 30 seconds. We interrogate where we're at as far as are we at a point where we need to scale up higher. I don't think it's one at a time though, Sam. And don't quote me, but I think every 30 seconds we evaluate and spin up the number of instances we believe we need. And then 30 seconds later, we'll evaluate again and add 2 or 3 more. I don't think it's one by one. And then scaling down has a similar, but I actually don't know the periodic. I think we look every 30 seconds again. And eventually we'll scale to 0. And like I mentioned, that provides you with a free offering at that time. There's no cost when you're scaled to 0. You don't have to scale to 0, because I'll say one thing. You mentioned cold start. When you do scale to 0, there's obviously the startup time of your app. And this is true when we spin up a second or third or 10th replica. That startup time is pretty much whatever your app requires in startup time. And we have startup probes, which will give your app a chance to start up if it needs a little more time before we start checking the readiness probe. The readiness probe is something we'll call into an endpoint that you supply, if you supply one. And when you say, yep, we're ready, we'll then count that service as ready. And then the last thing is a liveness probe that will continually ping on that liveness probe to make sure your app is still alive. If it fails, I think 3 times in a row, we'll actually restart your app. That's just part of the Kubernetes infrastructure that we're leveraging. But anyways, that's kind of the startup. But a lot of the time, how long does it take? That's really app dependent. Obviously, there's a little overhead for the container app and the Kubernetes behind it to do the work it needs to do, but it's pretty minimal compared to your app startup time.
Yeah, for sure. And you can see that it actually scaled up to 20 fairly quickly. So a lot of it was just due to the way that my that my app kind of starts up. So yeah, we're up to 20 now. It didn't take too long. It looks like it already kind of processed everything. And these replicas kind of stay up for a little while. So say I drop another 100 or so in there, it will kind of use those same replicas again. I think there's a certain amount of time that we wait for cooldown before we start scaling down. And then another way to kind of combat cold start is this kind of concept that we call that we have called idle. So what you can do is instead of setting the number of replicas, the minimum number of replicas is 0. You can actually set it to 1, 5, or 10, whatever you want it to be. And these are kind of like instances that you want to be always ready. And when they're not actually doing anything, and there's like different kind of ways that we can tell whether your app is doing anything. But if it's not doing anything, we actually charge you a much lower idle rate. So those things are always just kind of hanging out, just waiting for work to appear. But then there is no cold start because those containers are up and running and they're just waiting. And we're only billing you for HTTP workloads. We'll bill you only when it receives an HTTP request. So the time between the start of an HTTP request to the time HTTP requests end, that's the only time that we bill you for the active rate. And also for things like a queue processor in this case, we actually look at how much CPU you're using. And if you're below 0.01 CPU, basically 1% of a CPU, you actually build the idle rate. And we've kind of tested it with with an app like this, where you're just kind of pulling a queue periodically. And most of the time when nothing's happening, you're basically paying the idle rate. So that's how we kind of give you options to get around cold start if you want, basically for this thing to scale up to say 20 in this case instantly. yeah, you can opt to kind of use the idle mode.
Okay, and then does that mean that does the container size really impact cold starting at all, or is it not that big of a deal, or I guess what's the picture there is how much impact does that have?
Yeah, it does. It does have an impact because the system has to pull that container down from ACR or MCR or wherever, whatever container registry you're using. So the size of your image does matter in that case. And we do that. The reason we pull every time is just to make sure that we always have the most recent version of your container instance or your image. I'm sorry. We want to make sure the most recent container image gets pulled. So whenever we restart or spin up a new replica, we do go and re-pull that image. So that's why the time and size does matter. Does that answer your question, Sam?
I think so. Yeah. Before I launch into a bunch of questions, and I don't know if you're quite done with your demos yet, but if anybody else in chat would like to ask any questions for the team that built this, or maybe has been using container apps and wants to share their experience so far, please let us know. Other than that, I have questions.
Yeah. Well,
Yeah,
first, I want to say that. Dang it, Anthony's demo was way better than the one I was going to do. I have to admit.
Oh, really? I don't know about that.
I didn't have cats. I didn't have dogs. No, it's embarrassing how much better his was. So, well done, Anthony.
Nice, thanks.
So yeah, Sam, if you have a couple more questions, I know one that we get a lot, so I'm just going to ask it for you. Is, hey, do you support Windows containers? And no, Linux containers is what we support today. Yeah, that's that. So just want to get that
awesome
out of the room. Yeah, cool.
that was one of my questions, actually.
It always is, and so yeah, cool.
So I guess I kind of want to start just by looking at containers on Azure as a story. There's lots of different ways you can run containers on Azure, from AKS to Azure Functions to this. How do you recommend making that choice? When should somebody use container apps versus maybe choosing something more complicated like AKS, or scaling back and choosing something more serverless like Azure Functions?
Anthony, you want?
Yeah, I can try to take that because
okay.
yeah,
I also have a docs. I also have a docs page that I want to show. Just that we kind of have that answer to a certain depth in a docs page. So we should show that.
And then Googling that.
I just did. I use Bing though. To be honest, I use Bing. I didn't use Google.
Oh, look at this! It's the first thing that came back. So there we go. So we do have a doc that actually goes through and talks about the different ways that you can run containers on Azure. And to be honest, I think there's probably a couple missing from here because pretty much everything runs containers now. But yeah, so we try to do our best to kind of tell you the pros and cons of each one. And you will find that there is some overlap between between a lot of these. But the main one between, the folks who are using container apps are kind of comparing to is probably Kubernetes. So, so Mike, do you have any thoughts about, the differences between container apps and Azure Container or Azure Kubernetes Service?
Absolutely. I have a couple. I know you have probably some more insightful ones, but container apps, I love Kubernetes, and our Azure Kubernetes Service is awesome when you need it. And I think that's the key. Is there's so many times that you don't need the full, that's not power. That's not the right word. Configurability. Azure Container Apps has so many knobs, and there's so many open source third-party things that you can install in an AKS cluster because you have the full power of the Kubernetes CLI, kube control, anything you want. But that's a lot of complexity and a lot of knowledge, and you don't need that with container apps. And you get our opinionated take on AKS. And yeah, we don't offer every knob. We don't offer every knob on purpose. And so I think it's so much easier to run many of your workloads, your container workloads, on container apps. That's probably That's probably the biggest one for me. Yeah, I'll stop there. That's my story.
That was one of the big things I noticed in your demo. There was no YAML in your demos.
So YAML.
If you want YAML, I can give you YAML. We but we might be spending a whole hour trying to figure out like a bad indentation.
Yeah.
But yeah, like we do
YAML.
support YAML too if you like YAML.
Yeah, but yeah, exactly. If you do want to use YAML, so you can go to the portal. You can use the portal UX to create an app. You can do it through the CLI. We got some really great ways to do it through the CLI. In fact, Anthony could probably show us. We have an AZ container apps up command. So with a single command, it'll create the environment, the app, all in one command. So it's pretty great. Or you can use YAML if you want something that you want configurable and repeatable. YAML's a great way to do it. So I often start with the portal or the CLI. And then once I have an app that I want to recreate and redo many times, maybe through a CI/CD workflow, and I want that checked in so I have a version history of that YAML, I'll use YAML. Or I'll use Bicep. Bicep's another great way if you're a fan. I mean, of course, you can use ARM, which is Azure Resource Manager, and that's one syntax. But Bicep is a much more modern, I think, easier, more readable way to get. So you have all those options. We just showed you some easy ones to get started with. And then, of course, our tooling, our VS tooling and our Visual Studio Code tooling, which doesn't require any of those. So you have lots of options, I feel. Sorry, I kept thinking of new ways to deploy. I had to list them all. I don't have a favorite child in this case.
Yeah, I've been playing with Pulumi lately for deploying these. So you can actually write in C# or Python or whatever language you like and deploy straight to container apps. So
yeah. And we should mention Terraform because we now are listing all of them. Terraform also.
Okay,
So,
but I think that leads into one of the things that isn't supported. I think that's Helm, right? So Helm, for example, isn't something that you would use in container apps.
Helm brings the complexity of Kubernetes, which we want.
Right.
We want you to be able to avoid when you need the power and complexity and configurability of Kubernetes. It and Helm are great, but we're an alternative where you don't always need that complexity. So I think that's the great thing about container apps.
Okay, awesome. I did have a question about, I guess, kind of building on that. Open source things that rely on Kubernetes resource definitions and defining Kubernetes resources like deployments and pods. Do those translate well into Azure Container Apps? Is there a way to maybe migrate? Maybe if you just you want to run a web service and you happen to deploy it into Kubernetes because that was what was available, and now you want to bring it to Container Apps. What's the best way to approach that?
I'm not an expert there, and I won't speak for Anthony, but I know Kendall, another PM on our team, has actually done some demos where she shows that I think both directions. It's like, hey, if you start with Azure Container Apps, there are a lot of concepts that apply over to Kubernetes, and if you just munge your YAML a little bit and put it into the Helm manifest way, and vice versa. And when you talk about pods, what Anthony just showed you with replicas, what we call replicas spanning out, very similar to pods that can horizontally scale with the horizontal pod scaler. So yeah, what we do under the covers is one thing, and what Kubernetes does is often very similar. You'd be surprised. You shouldn't be surprised, right?
Right.
Because we build those same technologies.
Yeah. So typically, what we would see customers doing if they do decide to move to Kubernetes is that they would take their containers with them, and none of that changes. They might change the way that they implement the ingress or service mesh, or they might decide to use a different way of scaling. But for the most part, they would just install those components on their own into their AKS cluster, and then just run their containers that way. Obviously, they have to make some changes so that if they decide not to use Kata, for example, for scaling and use something else, or if they decide not to use anything that's Envoy based and maybe use something else, then there might be some changes there. But for the most part, the containers are going to be the ones that kind of have most of what your applications are made of. but the stuff around it might change slightly. And you probably see the same thing moving from AKS to container apps. You would just take the same containers that you would run in AKS and run them in container apps. There'll just be a different way of actually setting up the scaling and all that stuff.
Cool. You didn't really cover this in your demos, but revisions. I've seen this in some of your apps. But I'm curious what that is, because that's something that I'm not familiar with coming from Kubernetes. And so, what are they, and why are they useful, and how do I use them?
Yeah, that's a great topic. I wanted to make sure Anthony or I covered that. So thanks for asking that, Sam.
Sure.
I think, Anthony, unless you have a pre-canned demo yet again, that's probably way better than mine. We should probably show the UI in the portal, because I think that is a good place to visually show revisions. And by default, when you create an app, we do it in what's called single revision mode, so that there's only one revision. And when you deploy another version of your app, we just replace that revision. But you can switch over to have it to be in multi-revision mode. And I think Mr. Anthony is going to show that screen. And then you can have multiple revisions of your app that you can do, like, say, traffic splitting. And I'll stop and let Anthony show you that.
Yeah, so by default, we actually keep things fairly simple. We set your app to single revision mode. So behind the scenes, as you're kind of deploying more and more kind of updates to your app, we are kind of deploying new revisions behind the scenes and then switching traffic to it. And so if you wanted to, you can actually go back to previous revisions of your app. But we kind of keep that almost hidden from you by default, so that you don't have that extra kind of concept overload until you get to a point where you think, oh yeah, I actually could use revisions for things like traffic splitting. That's when that you might want to have multiple revisions in play. So we can actually create a new revision here. So by default, it's going to basically take what's in the. Actually, hold on. I think when we switch revisions, maybe I need to refresh the page just so that it knows I'm in the right revision mode. Oh, actually, I can't choose it because I only have one revision. That's why. But I can go ahead and make a small change to my app. So for instance, I can add another environment variable called background color, manual entry, purple, save. By the way, that's like that's a not everyone knows this secret, but you can actually set background color on any app and it changes the background color. Did you know that?
Are you being funny? Are you being kidding?
Yeah, I was just kidding. We built that into the app.
Nice.
I was like, what? No, I didn't know.
Yeah, it's a special word.
Oh, I wish I had something to throw at you, Anthony, but you're in a different country. So
I know. You can throw it. Yeah. Yeah, you throw it at me, customs is going to take about 50% of it. So. All right. Actually, you know what? I'll skip this part first. I will kind of go ahead and now show you the newly deployed site. And it should show, let's see if I got the right revision. It should, yeah, so I should have 100% to, oh, it's still to the old one, which I guess is fine. So we can now actually switch traffic to 50% old, 50% new, and then test out this new background color that we just added. So that's going to take a few seconds to update the ingress.
Which is Envoy. Again, opinionated. We chose Envoy as our ingress controller. And so we've configured Envoy for this app to be 50-50. And yeah, awesome, purple.
Yeah, so if I refresh the page, sometimes I get purple, sometimes I get the OG white color.
Very cool. You know what, Anthony, I never noticed, but that purple goes really well with my Rush Moving Pictures album art.
That's why I chose it.
Wow, you're amazing.
I know. That was just random.
All right. We do have about 5 minutes left. I do want to leave little bit of time open in case anybody does come up with questions. Otherwise, is there anything either of you want to answer or bring up or suggest for people to try out in container apps? Maybe there's a place for people to go for samples or something like that.
Yes. We do have some samples. I did not prepare that link, but I will find it if Anthony doesn't beat me to it. This is where Google or Bing is just usually pretty good.
Yeah, we have Azure Container App samples. You can just more or less Google Bing it. And yeah, you can see that it's actually a page on our docs. And we're going to add more and more to it. Right now, we have quite a few ASP.NET samples, but we're going to add more for different languages as well.
Awesome.
Yeah,
Yep.
and then you can.
And then we have a couple. We have a couple on Architecture Center where we have some more complete, I'd say, apps. We have one which is I think it's nicknamed or it's named the Red Dog. I think it's a pharmacy type app, I believe.
Yep, it looks like this if you bring it up.
Yeah, and then there's another one that is a drone delivery app, which is pretty cool. Ooh. And the architecture in that is nice. It uses, I believe it uses some queues and stuff like that. But both of those, they're in the Architecture Center. Definitely look at those. Nice.
Yeah, and the Red Dog one is pretty cool. It uses Dapper throughout, so you can see things and it integrates with application insights, so you can actually see the topology of your application. You can actually click on different parts of it in application insights to actually investigate any kind of slowdowns or trouble that you might have. And you can actually really drill into the end-to-end transactions of your application.
Yeah, actually, that's a great point, Anthony, about App Insights. And I do want to mention that when you use Dapper inside of your app, which is built into the app, the app container environment or service, you can use App Insights for that additional app tracing type information. You can also do that in non-Dapper apps and get what Anthony's showing you right here. I want to mention this because we don't have this built-in no-code solution yet. We hope to someday in Azure Container Apps. But for now, you can still use App Insights in all of your container apps, even if they're not using Dapper. You just have to install the SDK and add code where you want specialized events. But you'll still get this same interface that you're seeing Anthony show. A little more work, but an amazing amount of traceability that you get at the application event level when you do that.
That's super cool. That's distributed tracing directly in your container app. So you
can see an order comes in, it actually flows through a bunch of queues and actually hits all these different services. So you can actually see end to end a single order and what happens to it.
And again, that's built in. When you use Dapper, you get that almost, if not for free. If you're not using Dapper, you have to do a little more work today, which we hope to make even easier in the future, but you can leverage that Dapper or not. That's and Dapper gives you a lot of other great benefits, not just tracing. You get the service discovery. I think Anthony, you mentioned that earlier. Or Sam, that's a great way to do service discovery using Dapper. Dapper has a number of other benefits around stateful storage. So if you have a little state you need to store, they have some really easy ways to do that. Just, I'd say 5 or 6 or 8 of the most common microservice type things you need to do. Dapper makes it really easy to do. So check that out if you're not looking at Dapper today. It's definitely a great thing for microservices.
Dapper's, yeah, I like Dapper.
Yeah, me too. I like it a lot.
Awesome. So we are about at time. So I do want to thank both of you for joining us and sharing these awesome demos and a little bit of context about what Container Apps is and how people can take advantage of it. I learned a lot, and I really appreciate that. And I think a lot of people in chat also did too. So thanks so much. If you tuned in late to this session, it will also be up on the Microsoft Reactor YouTube channel. So you can catch it there. Other than that, there are a number of other sessions covering other parts of build the rest of this week and next week. So if you would like to catch up on other things like .NET MAUI, we're also talking about those later this week. So yeah, other than that.
And, one thing, just real last kind of thing is we have a great Discord channel. or server, if you want to come and talk to us or to lots of other great users. Discord channel is a great way to interact with both us and other users. And I know we're out of time. And the other place is GitHub, GitHub Microsoft/Azure-container apps, I think. If you have any issues or feature requests, Anthony's showing you that right now. Come to the issues, log an issue or feature request. Anthony, you're amazing. I mean, no, I'm not going to say you're like my Vanna, but anyways, you're doing a great job showing this. But yeah, that's the easiest way to get a hold of us and to report issues and feature requests is through the issues or Discord for a more one-on-one chat with people. And thanks, Sam, for putting this together and letting Anthony show his awesome, way better than my demos.
They were both pretty good. So yeah, thanks everybody. Thanks for tuning in, and thank you both for sharing. I really appreciate this. So Firas.
Great. Thanks. Cheers.
Thank you.
I just want to say thank you, everyone. Thank you so much, Mike, Anthony, and Sam, for this session. Before everyone leaves, if you have a couple of minutes, please go into the AKA link. I just dropped it in the chat, and use the code 16246 to tell us your feedback about how this event went. Other than that, thank you so much, and have a good one.
Thanks. Bye-bye.